Hello, myself Vinay. I am going to explain the uh, round robin scheduling. Round robin scheduling. This is our flow chart, which is this is the place where we all processor wait for their turn. The CPU picks the first process from this queue, that is the ready queue, where the next where we select the processor. The processor is taken from the ready queue to run, and it checks the burst time. If burst time is less than the time of the quantum, if the less than the time of the quantum, it checks, and the processor needs the less than the quantum size, then CPU finishes its on go. Next, burst time means which much the CPU which, which much the CPU time the processor still needs quantum time. The fixed time slot for the example quantum size is 2 milliseconds or 4 milliseconds, and the executions continues. The execution time of the time for the quantum is the CPU runs the processor for the exactly quantum time. Example, the quantum size is 4, burst time is 10, then CPU runs for the 4 milliseconds only. Next, the process is executed completely. If the burst time becomes 0, meaning means the process is completed and goes to terminate. If no, that's it. It backs comes to end of the ready queue. This ensures the fairness. And while coming for the program, this is our program. This is our program, and first we take the number of processes, that is n is equals to input of number of processes, and for the next we will see the arrival time and burst time for each process. Enter the quantum. Next, we prepare useful lists, that is arrival is equals to p of 1, where p of 1 it is comes under the process where it is the empty list. Next, next p of 1 is arrival time, p2 p of 2 is burst time, and remaining is the which is remains at burst times. Next, initializes the tracking variables. Sum of the called as time is equals to 0, complete is equals to 0, where time means current CPU time. Next, completed means number of initial process. Next, waiting time, WT means it is a waiting time. Next, TAT, that is a turnaround time. Next, ready means ready queue. Next, Gantt is the execution order. Next, main loop, while completed is that completed is less greater than n. Yeah, it is the main processor. It runs until the processor completes, and we add a process to ready queue, that is for I in range of if arrival is less than or equals to time and remaining greater than 0, and I not in a ready. It is any process can which has arrived still as the burst time is left and as it to the ready queue. Next, CPU it is if not ready, it is if no processor arrived, increases the CPU by time by 1. Next, we pick processes by a ready queue, that is IDX is equals to ready dot pop off and Gantt dot append of process IDX of 0. Next, runs the process for a quantum time. The runs the quantum for the, that is execution time is equals to minimum of quantum, that is this. If a process needs the less time, the runs till completions. If not, runs only for quantum. Next, add new arrived process, that is here for I in range of for if arrival is less than or equals to time and remaining is greater than 0 and I is not in a ready, which implies that if any new processor has arrived, the CPU was busy, added to the ready queue. Next, if process is still running and push back to the queue, which gives the if remaining is IDX is greater than 0, the ready dot appendix, because round robin gives the equal chances for the process goes back to the queue. Next, if process is finished, uh, uh, calculates the completed time. Next, completed time, that is CT of IDXE. Next, turnaround time, waiting time. Next, finally we calculate the averages and the final output. By seeing this, I can easily summarize that first user enters the arrival and the bus time of all process. Then the program uses the round robin logic with the ready queue. Each processor gets the CPU with a fixed quantum. If it's finished, it's go back to the queue. When a processor finishes the WT, that is the waiting time and turnaround time as calculated at the end. Average waiting time and turnaround time are displayed along with the Gantt chart. Thank you. Next will be continued by Mallikarjun.
Hello, myself Mallikarjun. Today I am explaining about the output of the code. Enter the number of process. We take a number process like four process. In enter the arrival time and the bus time process like one, and arrival time take a 0, bus time 10, and the next step will take on the same procedure like arrival time 1 and bus time 4, and next step arrival time 2 and bus time 4, arrival time 3 and bus time 7. Enter the we take the quantum number like a 2, and then we take a quantum number 2, and we output like shows the output like a Gantt chart like a, and P1 P2 P1 and P1 P1 P2 P3 and P1 P4 P1 P2 P2 P3 P3 P1 live, because the reason for the arrival time 0, the increasing order of the arrival time and bus time, the average waiting time like 8.3, average turnaround time is 13.25. In the observations like CPU time, each fixed time a quantum was used. First, we take a quantum number 2 like the Gantt chart like this, and next we take the quantum number 4. There is a Gantt chart, and there is a Gantt chart like this, and we take the quantum number like 6, and this is the Gantt chart of quantum number 6, and we take the quantum number 8. This is the Gantt chart of the quantum number of 8. We takes the observation for the quantum number like process that did not finish within the quantum where the moved back to end to ready queue. When the time quantum was small, the number of contexts which is increased. The number of contexts which increased, resulting is more word where when the time quantum was large, the algorithm behind the more like a FS, like a first come first out, or first come first serve, reducing the fairness but decreases the context switching, and process with the short burst times are completed faster because they require fewer cycles. CPU idle time occurred only when no process had hovered over, otherwise the CPU remained busy executing the program. Turnaround time increased slightly as all processes waiting for their turn is cycle. Waiting time depends on the number of times a procedure re-enter the ready queue. The Gantt chart clearly showed a repeating pattern, proved that round robin works for in a cyclical way. The program the program was correctly calculated by the CT, TAT, and WT, and average waiting time and TAT. CT means completion time, and TAT means turnaround time, and WT means waiting time. This is the observation of the quantum number. Thank you.